explorers! We are now in chapter 3 of today's lesson, and it's about mathematics in communication. A communication channel is a physical medium in which messages are transmitted. Examples of these are telephone lines, internet cables, fiber optic lines, and air. This communication may be affected by noises. Examples of these noises are lightning and human errors. The task of coding theory is to detect or even correct errors. It includes data compression and cryptology, where data compression is the process of encoding the bits structure of data that can consume less space on disk, and cryptology refers to a secret way of writing or hidden writing. Moving forward, encoding is a transforming of messages into bits of messages that are suitable to the communication channel. Decoding, on the other hand, is the opposite of encoding. Next is the parity check. It is the process that ensures accurate data transmission between modes during communication. It is an encoding scheme wherein a single bit is added to the message as a redundancy bit. Parity checking is used to detect errors in the bit string.
Add parity is a parity where the number of ones is add, while even parity is a parity where the number of ones is even. So for example of add parity, ano ba yung mga number na add? Can be 1, 3, 5, 7, 9, so on and so forth. While for even parity, dapat yung ones are even. So 0 including 0, 2, 4, 6, 8, so on and so forth. So here we are given an example. Perform the channel encoding by adding a redundancy bit of 2. So we can add a bit either 0 or 1 only. So the goal of doing a parity check is to end up with even parity. That's the goal of this example. So the first one is 0, 0. 0, 0 is an even parity already because there is no 1, meaning that 1 is equal to 0. 1 is equal to 0 because you don't see anything 1 and 0, 0. Now, ang hinihingi naman is a bit size of 2. So, dadagdagan natin yung given. So, from 0, 0, magiging copy the given 0, 0 and then add redundancy bit 2, 0, 0. So there are 4 0. The final answer now is 0, 0, 0, 0. Therefore, it is an even parity because again, walang 1 sa answer. Next is 0, 1. Look at the end of the number, which is 1. Then add a bit size again of 2. Now the answer would be copy 0, 1 and then add bit size of 2. What's the ending? It is 1, so we will add 2 ones. It will become 0, 1, 1, 1. So you notice the number 1 is 3. It is an add parity. There are 3 ones in this. It can derive as an add parity. But then, our goal is to end up with an even parity. So, to make it even, we will add 1 at the end. Making it from 0, 1, 1, 1, it will be 0, 1, 1, 1, 1. To make it that the number of ones is 4. It now means that it is an even parity. Next is 1, 0. Again, like we did previously, we will look at the end of this bit string. So it's 0 and we will add 2 bit size. So 1, 0, copy the given and then add 0, 0. Since it is an add parity, we only have the number ones. We will do it as an even parity by adding another 1. So it will be 1, 0, 0, 0, 1. Okay, notice that we added 1 at the end of the bit. To make it like the number of ones is 2, and it is now an even parity. Next is letter D, 1, 1. For our last letter, kayo naman muna ang sumagot. Pause the video for a few seconds and try to answer this. So now, let's answer the question and see if you get the right answers. So again, 1, 1. 1, 1 is already an even parity, but we will add a bit size of 2. So copy again the given and then add 2. It will become 1, 1, 1, 1. It is already the final answer. Did you also get the same? It is already an even parity because the number of ones is 4. Okay, another example of parity check. If you have a given 1, 0, 1, 0, 1, and then there's an x. X is the parity bit that is missing. To make it an even parity, number of ones including the parity bit is even. So, copy first 1, 0, 1, 0, 1. What would be the next number to make it even parity? Again, count the number of ones. In this case, there are 3 ones in the given example. And then to make it even, we will add another 1 at the end. Now, notice that the number of ones is now 4. And it is already an even parity. Next, how about if we make it an add parity? Again, copy the given 1, 0, 1, 0, 1. And there's the missing. The given example is already an add parity. Since the number of ones is 3, already, it is an add parity. So we will just add 0 at the end, making it 1, 0, 1, 0, 1, 0.